So here we are talking just like as a reminder, like as you're solving equations. If you have multiplication, the opposite of that is division. Same thing with division. If you have division, it's multiplication. Adding, subtracting. So as you're rearranging these equations or solving for y, you should always be thinking like, what is the opposite? What is going to undo what is currently happening? So adding, subtracting. If you have something squared, you are square rooting it. If you have something that is square rooted, you will square it to undo them. Those are opposites. Cubing and cube rooting works the same way. And then the one that I'm going to talk about and focus on in this video is exponential versus logarithmic. And we are going to go into exponential and logarithmic in a few weeks. So know that like this is not the end of this conversation. I'm just kind of introing this to you so that you can kind of see like, hey, exponentials and logarithmics are inverse functions of each other, and we will see kind of how those play out together. But if you have an exponential, you're going to do the log to undo it. If you have the log, you're going to use the exponential to undo it. So let's look at some examples of that. So here I've given you a log base 3. So on the last page it was log base 4. Here it's log base 3, x minus 7. And so here, just like I've done before, I'm going to rewrite this as y equals log base 3 of x minus 7. And then I'm going to switch my x and y's. So here I have x is equal to log base 3 of y minus 7. Well, here the y is inside, and so I can't do anything with that while it's still inside, and so I need to get rid of the log. The log is the outermost part, and I have to undo that with the exponential. And so if I take whatever's happening here, and I say 3, and I'm going to raise it to the x power, or I take 3 and raise the whole thing to that exponent, the base, as long as the bases are the same, they will undo. And so that's why I chose 3 here, because this base is 3. So 3 to the log base 3, those undo one another. And so all that's left now is y minus 7. And on the other side, I have 3 to the x power. So now it's an exponential function. But I want y by itself. And now it's a nice, easy, simple equation. I'm going to add 7. I'm going to add 7. And y is equal to 3 to the x power plus 7. Rewriting that as an inverse function, I have 3 to the x power plus 7. There we go. And so let's look at one that is already exponential, and we're going to use the logarithmic to fix it. So here, same thing, y equals 5 to the 2x minus 1 power, and I am going to switch x and y just like I have been. X equals 5 to the 2y minus 1. Same thing here, the y is trapped in the exponent, so I can't like add, I can't subtract, I can't multiply with that until I take care of this exponent. And so the bases, just like before, need to be the same. But this time, I'm going to take the log of both sides. So it's already exponential, and I'm going to take the log base 5 of both sides. So same thing here, log base 5 of 5. Those undo one another. And so I have log base 5 of x on the left side, and all that's left on the right side is 2y minus 1. Solve equations, just like we always have. So I'm going to add 1. I'm going to add 1. And I have 2y is equal to log base 5 of x plus 1. So the plus 1 is outside of that. The x is all by itself within that log. And then plus 1. And then I can take all that and divide by 2. And so f inverse of x is equal to log base 5 of x plus 1 all over 2. You could split that fraction if you wanted to. Log base 5 of x all over 2 plus 1/2. But this way is perfectly acceptable. Okay, so hopefully that helps on logarithms and gives you a little bit of intro into logs and what that will look like.